All right, welcome back. How you doing? I'm Agent Ultra, and this is my stream. I don't know what to call it, but this is where I write some Haskell and we do some fun stuff. So if this is your first time tuning in and checking this out, we're in the middle of building a Asteroids clone in Haskell. And just to give you a taste of what that looks like, currently where we're at with the project. We have our little ship here. You can blow up other asteroids. We got a score counter in the top left. We added ship collisions, so you get game over if you collide with an asteroid. All right, so this week, we're gonna add more like scene transition handling type stuff. And maybe get rid of that hitbox there for the ship. But there you go. So that's the game so far, and that's what we're going to work on. So I'm going to open up my project, Asteroids, game. Cool. So let's get rid of the ship collision box rendering and the debugging. Let's get rid of the debug trace there. No more instances of that. Okay. Small commit. Okay, next, let's let's remove the hitbox rendering of the ship. Jump over to render player ship. There we are. That. Everything should be just as it was before. Mirror, mirror, mirror. Oh, except I don't have my builder running, so let's run my builder. Stack build. Fast. File watch. We have some type errors. I gotta probably fingered something funny. $756. There it is. Okay, so that should build, hopefully. A couple of warnings we could clean up, but let's just make sure that rendering's gone. Yeah, so there used to be like, it was kind of hard to see-ish maybe on the stream. But there was like a little blue hitbox being rendered inside the ship. Now it's gone. Another small little commit. Okay. And warnings. Let's clean up some of those warnings. The qualified import of video is redundant. Okay, so that means we could just remove it. And on 144, we have a redundant apply. And the rest, so maybe, yeah, those ones I'm not too worried about. This one's never used. Okay, there we go. Let's create a little commit for that. And just some minor warnings cleanup. Okay, let's rebase all of that together. No, actually. Yes, from here to here, squash that all up. Mm-hmm. Clean up. Okay, cool. So now that we're starting from a decent place, the next part will be this game over screen. So what we want to do with this is to, like, when we get the game over screen, as you saw there, it just displays the game over texture. And how come that's back? For some reason I just saw the hitbox being rendered again. Let's force a rebuild just to be sure. Okay, that's better. So we just get this game over, right? But obviously we might want to render something else and like do other stuff when this game over screen. Like maybe we want to like stop simulating the game and like just display the score, a game over, and like a menu, like start again or what have you. Maybe you want to like a leaderboard that you want to keep around something. But basically the idea is we want different things. We also want to have like a menu as well when we start up the game. That should be like the first thing you see is like the title of the game and that kind of stuff. And maybe some menu options there too to set different parameters of the game before you start. So in order to do that, we need to like figure out how we're going to render different scenes. So each of these like sections of the game, like the menus and game over screens and such, are what I typically call a scene, and a lot of game engines will as well if you use things like Unity or Godot or whatever. That's something like some kind of abstraction like a scene, which is comprises of like the main kind of loop and like the things you want to render in it and like how to update it and like all the input, get all the input for it and such. So we kind of touched on this last week when we implemented this game over stuff, and I think we can just build on that from there. So if we go to the game state, so this is going to be like more of a refactoring kind of thing. If we go to the game state, we see the game state status. And that's this game status type here, which is either playing or game over. That's it. We could add more. It could be like, main menu. Maybe we add a pause menu. Right? And then these different statuses, when we're in different, they're like kind of like the different screens of the game that we want. Hey, Swarm Collective, how's it going? Welcome back to the stream. Nice to see you again. And so we want to switch something about this game and how it renders and the input it accepts and the updates it does depending on which status we're in, whether we're playing or game over, menu, and so on. So I think we need something called some kind of abstraction called a scene to take care of that. And so we'll create a scene, and then the game state will have a scene to work with. And the scene will have essentially the loop, and that like the input handling, the loop, and the rendering function. All right. I think that's what the scene's gonna do. And then we need like some kind of run function for it. So that the game then becomes more, all this code basically comes, yeah, switching out the main scene. So we can transition and stuff like that. So anyways, less talking, more code. Where are we gonna put the scene stuff? Let's put it underneath game status. Scene. All right, so we need to bundle together what do we need to bundle together to make the scene actually go? That's the question. Input handling. Let's check input handling, how that works, right? Because we want a scene to handle inputs differently. If we're on a scene that represents a menu, we want up and down buttons to do different things than when we're in the gameplay scene. Similar with the game over and things like that. So we're going to need to like extract out the input handling code and put that into our scene definition. So when we do run, I think we do all of our input handling here in the top of loop. All right. And the whole point of input handling is to produce this button state, like the next button state. Which is fine. Then a new time and a new frame. And we have this update that happens. Where we update the state, we integrate all the updates that we want to do. Then we render. Then we do some extra logic here outside of the update where we update bullet ages and spawn random asteroids. And we might need to clean this up in order to do this. And kind of put this, feels like this kind of should belong inside of the update. And then render. All right. And so our scene should just comprise of update, this handle input stuff, whatever that's going to look like, and render. So 3 functions. And then this entire section, this loop here, can just be mostly getting the new delta time from SDL, calling the scene's update function to create a new game state, and then calling the scene's render function to render the current game state, however the scene wants to do it. And that should let us kind of bundle up the logic we need to render the main game scene. And that'll be our first refactor, our first step in the refactor. And if that works, then we should be able to do it for the main menu and the game over screen and stuff like that. Okay, so first, the easiest part will be, well, we know we need to do update, and the type signature of update is game state to game state. So let's add that to our scene definition. Scene update is just game state to game state. And scene render, we have a type for that as well. I believe that's game state to IO unit. Right, yeah, game state to IO unit. So the only thing we need is input. And what should the type of that be? Probably game state to game state. And as long as we have these three things, we should be able to, sorry, wrong key combo. We should be able to, wrong key combo because I have Haskell cat in my lap. We should be able to, yeah, create other scenes and stuff. So, this is a record of functions, so we can't really define, we can't really derive equal or show for it. So I'm going to see how debugging is going to be interesting for this. Should be fine. So we're going to have to go ahead, before we can actually implement scene, for like our gameplay scene, we need to extract out a function for scene input and fix the other thing. So let's do that. Let's do input. If I was going to write this function, though, loop should handle calling SDL and polling for the events, I think. So maybe our input function should be the list of events that we get this frame. And then it handles, and a game state, and then it handles giving us a new game state with all the button states set. Actually, Actually, sorry, that's all this code does here. Maybe we don't need an input handling function because the scene update seems to do all of that stuff. This just sets the button state. All right, and so we kind of just define like our game has an up button, a left button, right button, down button, fire button, blah, blah, blah. If we wanted more, we would add more. But we can update all, and this just sets the release and down state for each of these keys. And then our update logic handles actually reading those button states and stuff. So yeah, I think I was getting a little bit ahead of myself there. We don't need the input handling there because that can just be read by the update function. So let's get rid of that. Yeah, it's just scene update and render. So as long as we can fix the other part, where we have the kind of the spawning and stuff happening after rendering, or like just before, if we can move that back into update, we should be good. Why is this happening after rendering? I don't even know why it's happening after rendering. Okay, so let's see if we can move that code. Actually, let's just make a little quick commit, and then we'll see if we can move that code into update. Right, because this just adds the scene. Add a scene type that encapsulates the update and render logic for a scene. Okay, and then jump back down to loop. Let's go, yeah. Get these two functions. And go to update here. So we can handle the collision results. Get the new ship. Calculate the next state. We can call. So then if the game state accumulator is less than the delta, then we call next, and then we return the next state, otherwise up to the next. So I think the logical place to put this next state, those two functions here, is right there. Yeah. And then we should be able to remove this line here. Right there. And all is good, and that compiles. We should see no change in our game and how it behaves and works. We're just moving code around. All right, so bullet handling, update works still. And then asteroid spawning should still be the same. And there comes a spawn on our asteroid. So I think it's safe to say that's all good, and we got our game over. The ship collision. Okay. Stage that. Work in progress. Move the asteroid spawn. And bullet timer updates. And then we can now I think we can change the loop code. So let's implement our scene. So where do we put the code? Okay, so this update function and this render function will now become part of our main scene, like our main game scene. Playing scene, I think we called it. Let's associate it to, it has kind of a relationship to this game status type. Yeah, playing. So our playing scene. I'll call it main scene. Our main scene or game over scene. Yeah, that makes more sense. Let's just fix that. Okay, and that's good. Okay, so then we'll call main scene. We can define it like this. Main scene is a scene. Surprise, surprise. All right, we're scene update is equal to update, and scene render equals render. And that should all compile. Now we can change loop We can get rid of update this and, well, let's add the scene. Yeah, we're gonna need to add main scene. I think we're gonna need to reorganize the module a little bit too before we're done, but all this jumping around is getting a little bit meh. So our init game state, we'll add the scene to it. Or just to our game state. Game state scene. Although we lose our EQ and show instance if we add it to the game state like this. That's fine. I don't think we're actually using those instances except in debugging. Maybe tests. It might break our testing. Maybe if I have any tests on the game state. I'll have to check that too. Okay, so now we need to go to init game state and add our game state scene. Main scene. And now that it's in the game state, when we call in loop, instead of just calling update directly, we're going to call the game state scene. No, not quite. Right, so instead of update, we call game. We call scene update. Right. And this might just be kind of an annoying record field type thing. Right. Game state scene. Right, and this will be scene update here. Okay, that's right. Okay. Now render the scene render, game state scene. Okay. Now that should all compile. And when we run it, it'll be exactly like it was before. All right, just a little bit of indirection there. That's all good. Okay. So we'll stage that, and now move state render from, or use main scene in loop. Use scene in loop, blah, blah, blah. We'll reword things to make it make sense. Okay. And so now we should be able to define a new scene for game over. All right. Game over scene. We'll have to call a game over update. Game over render. Okay, and we'll define it after update and render. Okay, so let's say game over update game state to game state. And game over render the game state to IO unit. Okay, so then we have to fill in these holes. I don't know what to do for with the what we want to do the update yet, but we already have some code for the render, so let's just add that. All right, instead of this, we can just cut that. We need to bring our game state into scope. Okay, we'll render nothing else. And then what to do for game over update. We could just change nothing for now. Let's just make it ID. Okay. And so now let's hook in we added the game over scene. Okay, let's do a quick little commit for that. Okay, and then we want to have the logic update, and we want to update the logic in the main scene to switch the game scene in this game state when we encounter the game over condition. So handle collision results. I think it's when we check the ship collision and the ship handle the collision results for the ship collision. This part. So we will return a game state where the game status is game over and the game state scene is game over scene. And that's how we will change the scene. So now it should compile as before. And now when we run it and the ship collides with an asteroid, we should get to the game over screen with nothing else rendering, no other updates happening. Just this. Well, the rendering isn't working, but the update seems to be. And that's probably because we're not clearing the screen in our render game over render. So we'll renderer, draw color, we'll set it back to black. Zero, 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 255. And clear. And then render the text. Game over. Okay. Now we should see the game over screen. Skaboink. Okay. We are not. Something is happening that we are not anticipating. So what is going wrong? I think that logic is all fine. Okay, so let's check. So collision checking. What could be happening here? Okay, so we do it in the handle collision check. Maybe what's happening is that we're still, when we're doing the handle collision results, let's see, we update the position, we get the next state, and next state is state prime, such that So state prime handles collision results. So the return of state prime should be, at least when the ship collision is detected, it should have a new scene in it. Update position doesn't change the scene. And now next state is calculated as state prime, where the accumulator changes. State ticks also change. This could be slightly problematic. Doesn't change anything about the scene. But what could be problematic here is that the update function for our game over screen is not updating these things that need to be updated on every frame, regardless of which scene we're in. So there might be parts we need to pull out. And from loop, as far as loop is concerned, yeah, we just call scene update. We call this many, many times. Yeah. So we actually our update function here contains part of our game loop logic, which we didn't mean to move in this refactor. Or we shouldn't have moved. Um, hmm. Yeah, so we need to pull this apart a little bit. Somehow. Hmm. So what I think is happening is basically we're changing the update function in the middle of this this loop, and then this condition never hits. So we always update to the next state constantly, and we never actually do this. I think that seems probably what's happening there. Does that make sense? Yeah, because then if we change the scene, right, we hit this branch. If game state accumulator is less than or equal to delta, and that's the current scene, game state accumulator, current game state. And if it's less than delta, then we spawn random asteroid and update bullet age and go to the next and on the next state. Otherwise, we call update state. So if this isn't going to, if we get to the else branch here, we're going to call ourselves with next state. Right, and then game state is going to come in here as the next state. That should be fine, yeah. Like we accumulated the next state thing. So this should eventually fill up and then get to this else branch. Or no, get to this then branch. And return. And then come into game over update. Maybe game over update is the problem. Because we just defined that as ID, so it changes nothing about the game state. It just returns right away, no matter what you do. All right. We're going to have to get debug in here. I think it could be that. Import debug.trace qualified as debug. Let's check out game over update first and see if we actually reach that update. We might have to just pull in. Oh, sorry, I'm putting. Not the wrong spot. Okay, so once that builds, let's run it now. We're not seeing it hit debug yet, but when we go to check a collision and change our function, boom. Okay, so we are getting to the game over update loop. And I'm actually getting the Q press from loop. So that seems fine. Now we're also handling the quit. Maybe it's a rendering problem? Did I remove that from loop? I did. Now let's Q pressed, we do loop state prime, which is our updated scene. That's a quick way to test this. I'll just run the debug statement to our game over render. Why not? Okay, so we're in our main scene. Game over render. If I press just Q, which the outer loop handles, quits. Yeah. Update the render, update the render, update the render. That's all fine. So it's something, it must be something with our rendering then. Oh, we're not calling SDL.present. Eh. Derp. There we go. This ought to fix it now. Kaboosh. Okay, that's what we want. Here. Okay. Yeah, so, I mean, let's commit that because that works and works the way we want. And then just quick, I just want to go back and re-review my thinking around the update logic there for the main scene. Let's see, work in progress. Um, oh wait, we want to get rid of some stuff first. Let's abort that for a sec and get rid of that. No more debug traces. There, okay. Do. Add game over scene transition. Okay, now update logic. Should we pull some of these values out into like kind of a more generic wrapper that updates some of these values? The ones I'm thinking are game state ticks and game state accumulator. I feel like these should be moved outside of update itself, or at least should be updated in every update function. Because, well, these are used for game state physics. Like the accumulator is used for knowing when we're done doing updates here. And ticks is how much time has elapsed in like kind of a more abstract unit. Ticks. We use... Now we use that in bullets to figure out like how long they've been alive for, basically. So how would I do that actually? Mainly I want to figure out if there's a way I can do that when I'm defining a scene like here, that it's done correctly. One way we might be able to do it is to have our own function that interprets running a scene. That can do the updates for us, like the common stuff that needs to be done for every update. That might be a way to do it. So let's go to our scene definition. So like run scene. Right? This would take a game scene, or game state, some scene, and then this would be actually IO game state. All right, so we get the new state prime. Or the new state. By calling, we could probably pull it with a record update here. Game state, or scene update. Sorry, not game state, scene. Game state appears on the right. We don't want to use record update with it. Scene update. Game state. That gives us another game, the next game state. And then we call scene render with the updated state. And then we return the game state prime. Now this almost looks like a bit of the same logic from further down in the loop. All right, we're calling scene update with the scene, we're calling scene render, and then we get the next state. We can replace those bits, I think, with this function run scene to get state prime. With state, I think we bound it to. And game state scene. Now the only thing a little bit different, we might have to just these variables here. So move them in here. It's kind of messy, but we'll live. Let's just be somewhat readable. Worry about the rest in a minute. We should be able to get rid of this now. Okay, and that should compile. No, of course I. Ooh, yep, that does need to be an IO action. Parser? Oh, yep. Yep. Now we're gonna compile. Good. And now let's check it out. So nothing else should change. We still should get our game over screen. Boom. Okay. That's good. Okay, so now we should be able to organize some of these kind of like managed game state variables that we don't want to have in our scene update logic necessarily. We want them to be updated like by the game loop itself. So let's commit that first, and then we'll do this next part. So we add the run scene function. Updating the game state and rendering it while managing game loop global variables. Okay. So we should be able to move this update. I think we should be able to move that update. No. We might not be able to. Because this happens recursively. So we might have to move, we actually might have to move this recursive check up out of update and put it in our runner and make the run scene function do this looping, maybe. Yeah, I think we'll have to move that logic up with it. So then this update function won't have to be responsible for calling itself, because it'll be called by run scene. And it just has to return the next state. That's it. I think that'll actually make this a little bit cleaner too. So let's do that. We can get rid of, well, all these let bindings will still be there. They'll just be it'll just be this then branch. And then this stuff here will move up into our run scene function. So we get the next game state. We render that game state. If the game state accumulator is less than or equal to the delta, we only have the one branch. Oh no, we have pure. So if that is less than the delta, then Then we call ourselves else pure game state. Now I have to give the scene a reference to the scene. Delta. We didn't account for that, so let's make sure we pull that up too. Where's delta computed? Oh, delta's a global. Right. Oh, sorry. Right. Sorry, that's my brain fart there. Okay, that should be good. Okay, if I got the logic right here, then nothing about running the game should change again. Just as before. Not quite as before, because now my input isn't registering. So I have to quit this. I ask the OS to kill it. Okay. So we're not doing the, yeah, that's right. It wouldn't work yet because we're not actually updating the variables we need to update because we haven't pulled those out of the thing yet. The update function. Okay, let's pull those up. Run scene. So it should be scene update game state. Where? Yeah, need these two variables. Wrap those in some curly braces, please. Okay, so let's bring game. Let's not. Game state ticks of game state. Okay, so game state prime has those variables updated after getting the updated scene from the function in the scene. So now the scene doesn't have to worry about updating game state accumulator or ticks. It can just read them. Of course, there's nothing technically stopping me from updating those variables inside the updates, but not worrying about them will just be mostly by convention. That's fine. This is like our application, right? We don't have to, we're not writing a library here. Okay, is my update working again? No. Okay, so we're still kind of getting stuck in run scene. We should probably do it that way. So the game state accumulator of the newly calculated game state is less than or equal to delta. Now we run state game state prime. Otherwise, we return pure. So that might have been it. That might have been quick on the draw here on the rerun. Okay, nope. We're still not getting... I'm still getting stuck. Okay, so game state prime, update, game state accumulator. Okay, so we ask for the scene to update the game state based on our input game state. And from that returned updated state, we change the accumulator. We take the difference of the input game state's accumulator with the delta amount. And game state ticks, we increase by the delta amount. And then we render this game state prime. So the newly updated stuff with all of these variables. And if the game state accumulator of that newly calculated state is less than delta, then let's see. Maybe I have the conditions flipped around the wrong way. Let's just check the diff. Right, so the logic we meant to pull over is that if the game state accumulator is less than the delta, then we return. Otherwise, we loop. So I just have these flipped around. There we go. Got game over. Cool, we can get out. All right. That's one spot, and I think there's one more place where we can move some of this up into that. Um, FPS might be one, but no, button state's fine. So these values are just being changed by the outer game loop. Things like the button state, the initial accumulator. Current time, FPS, the spawn timer. I feel like that's kind of not a main loop kind of thing, the spawn timer. It's not harming anything leaving it there. Although, if we're not needing to change it, like it's only used in the main game scene, yeah, then we should probably move it. Let's see, let's move that out. Let's go to update. Probably put it here. Oops. Outside the player ship. Here. New time, though, has to be moved. So we'll just have to get it from game state current time. And that should be good there. Just make sure everything's still running. There we go. Ba-bow, ba-bow. Game over. Good. Okay, that feels pretty good. Let's just check our code. I'll make another commit. Yep. That looks good. That looks good. Pretty reasonable. Okay. Move physics accumulator loop logic. Okay. Okay. Let's rebase this. Keep the scene type as a commit. That makes sense. So reword that one. And we can squash. Reword this one, squash these ones into it. Yeah, let's go with that. And we are on yeah, we're gonna squash this. And now we're on reword, the first reword. All right, so this is going to be the add add main scene and game over scene logic. So change loop update logic. Added a main scene and game over scene. Change the loop logic to call the current scene. Right. Added a main scene and a game over scene. Added a, actually let's do a list. A main scene and a game over scene and game state scene variable. Change the loop logic to call the current scene. To run the current scene. There we go. Didn't quite do that quite the way I wanted. Got confused there. Let's just reword that. There we go. Okay, that looks good. Good clean history. Like it. We have for time. 9:35. Perfect. We got a little more time. So let's see. What should we do next? Let's change our game over update function. All right, so game over update doesn't actually do anything. All we can do from there is quit. So let's make it so when we press the fire key, we can start a new game. So we have to test the button press. Key down, button state left. Okay, that's how we test it. When the key is down, let's bring the game state into scope. Remembering my little convention for now. If the type here appears on the right-hand side of an arrow, then don't use record update syntax. Or if a type appears on the farthest right of all your arrows, don't use the record update syntax. Or record wildcards. A record update. Record wildcards. So, anyways. So when the key down of the game state button state, game state, well, we have to tell it what button. Do something. Button state down. That's right. Oh, and we can't. No, we don't need to do when. This could be a guard. But that should be equals. Otherwise, game state. Sorry, composition is wrong. Key down. That'd be a little bit, not like that. All right. So if that is pressed, then how are we going to start a new game? We'll start with a function. All right, state. Well, we have to reset the asteroids, bullets, the player ship's position, and the score. And I think that'll be enough. The accumulator and stuff, I think, will be all handled. We have to set the game status back to playing. Main, sorry. Set the scene back to main game scene. Or main scene. Game state asteroids. And an empty deck. No, we should have like an initial couple of asteroids there. We'll get to that in a second. Layer bullets. Just game state bullets. Okay. So in case for the asteroids, we edit those game state. Literally this. So now we're going to use it in 2 places. Let's make it a constant. Init asteroids is a deck of asteroid. Looks like that. Now we replace this there, and then in our typed hole, also here. And then for our empty deck of bullets, that could be an empty one. I just have to look up our deck documentation. I think there should be an empty one. From lazy to lazy, stenographer, shift left, shift right, filter, take, drop, blah, blah, blah. Init. Oh, just the initial one. Eh. Eh. No empty, singleton. Gosh. I think maybe I want to pull deck out. I don't think we really take advantage of it enough. Does it have a monoid? Or semi? Generic hashable. Well, it does have monoid. So we can get an M empty for that. Okay. I think that should compile. Not quite. Right. Init asteroids is gonna have the problem. Because these aren't defined at a top level. Just put them there. Looks good enough for now. Okay, now we compile again. Let's get straight to score. Okay. Now let's get a score. Okay, so if I press Yeah, key button down is the one I think. So it resets it. That's nice. We should also reset the timer. Start new game. Yeah. Game state, asteroid, spawn timer? Need to fix that. Let's go the init game state. Oh, cool. We can call hopefully init player ship. And init timer with current time. We'll do it from game state current time. We'll set the game state asteroid spawn delta. Just grab those hard-coded, although now that we're using it in a couple places, we probably want to make constants of them. What else? Well, the bullet timers. Oh, we might want to refactor the bullet timer. The logic works fine. Let's not mess with that. So yeah, spawn timers, delta and factor. That's good. Let's add constants for those. So init asteroid spawn delta. 15. And we'll change that to init asteroid spawn factor. That, do that. Okay, successful compile. All right. So that should reset everything, hopefully, back to where we need it to begin a new game. Let's try and get it. Oh, missed our chance to get a game over quickly. Hopefully we get a new spawn time in here. There's our asteroid. Let's collide with it, get game over. All right. Last thing I want to change is just making that key, changing the key in the game over state. It's not key down, but key fire. Oops, key down, button state, fire. And then we should probably add some like helpful render text so users know. And render that 200 and like 220. Okay, that should work. And then we should be able to run it. See our little help message. Let's get our ship to collide. Oh, it seems harder than it seems. Ah. All right, there we go. All right, so it renders a little bit over our game over. Probably want to be able to render at a different size, the text. However, let's make it like 260. And pow, there we go. Oh, we start the ship, the player ship's position. Yeah. Okay, that's the last thing. And init player ship might not be the right thing, or this just needs to be at the top level. Init game state. Init player ship. Should just be a top level thing. Pull that over. Perfect. Okay, perfect, wonderful. Let's fire start a new game, and we start a new game. Maybe we can display like the score too. Let's render it above the game over. Um, we're going to need to... game state score. All right, we need a V2 position for this. Let's kind of try... Maybe we should center all of these. Somehow. If there's a way to center it. Let's just do it all on the same hard-coded X. We'll just do this at, like, 140. Let's get a cool score, and we got a score of 2. Game over. Sweet. Hey, Altos. Thanks for stopping by. Yeah, we're almost there. Let's see. Final score. Oh, it was a little hot on the reload there. And, yeah. Yep. Just using an SDL wrapper. Pretty low. Well, I mean, it's high level because it's written in Haskell, but yeah, like straight, almost straight up SDL. All right, final score 5, game over. Press fire, starting a game. There we go. Boom. We get our random asteroids going to pop in at some point. There we go. Might have to tweak some of these variables that we've created for this, but there you go. Cool. Well, that's all the time I got for the stream this week, friends. Let's just make sure we push up the code. Yeah, so all of this is just adding a better game over screen. So if this is your first time tuning in, the code for this all lives. Oh, right. Sorry. GitHub changed all of its SSH keys, didn't it? All right. I'm going to assume that's the right one. I'm not getting man in the middle. Probably not. But yeah, so if this is your first time tuning in, the code for this is on GitHub. I am Agent Ultra, and this is Asteroids, the project that we're working on. Yeah, that was super annoying. It was like end of day yesterday when I went to like go push my code at work, and I like totally didn't realize that was part of like their whole thing with the outage the other day, and I was like, what's going on? It took me a while to figure it out. It was end of day, so I left it till this morning, and then this morning I realized what happened and had to do all that. Anywho. Yeah, well, I mean, it's possible to pull off. It's pretty hard to do. And it's good to like verify that the RSA key you get back from their server is like what they say it is and what it should be. So check that. But yeah. So this is the code and where to get it. Agent Ultra. I'm also, you can follow me on the socials on the Fediverse at Agent Ultra at types.pl. You can also go to the declarative.tv link above here. We have a Discord server with a channel for this stream as well as others. There's a lot of other people who stream programming in like cool declarative languages, which includes like functional programming languages like Haskell, which is what I mostly do on this stream here. My usual times on Tuesdays in the evenings at 10 after 8 in the Eastern Zone. And if you're watching on YouTube, you know what to do there to follow and subscribe and all that. And you can do it here on Twitch as well, in case you want to get notifications about when I go live and all that junk and jazz. So it's been a pleasure. May all your monads be free and may your types always check, and we'll see you next week. Take it easy.